I don't think it really matters that much, but I always take care too. The short ones had blue Loctite and the long ones had red Loctite, so I always put them back where they belong. I don't think there's any way anything could get loose in here anyway, but I always pay attention to every detail I'm looking at. You should just always do that with every job you do. Everything in life, always pay attention to details. Something that's taught heavily in the Marine Corps. Always pay attention to details, because the details will get you. Life or death situations in war or something, it's the details that'll get you. So it's a good habit to keep yourself in. What I have here is a 2141, a 2019 16-inch MacBook. And normal issue, we've seen it on all the models since the 17s. The graphics mux. It's in between here. I forgot my screwdriver. Hopefully Lewis has some screwdrivers. There's a graphics mux in between here that changes the graphics feed from the CPU to the GPU out to either the USB-Cs or the internal screen here. So what happens a lot is that you get liquid damage on the internal screen on the connector here. If we look at the schematic and board view, right here on the screen connector, we have the PPV out SO backlight. So this is the highest voltage that you're going to find in a and pretty much any computer. This is the backlight voltage. The backlight runs on 40 volts nominal, I think, is when it's running. Well, let's see. Let's go to backlight circuit. Let's see if it says something here. That is not taking me to the backlight circuit. Let's go click on the backlight driver instead. Does this actually tell me the voltage out? The voltage out varies a lot, because depending on how bright you have the backlight. So, PPV out, SO backlight, voltage 59 volts. Let me zoom in and highlight, because I don't have any mouse cursor. Okay, I'll watch the mouse cursor on the screen. Voltage 59 volts. So this is the highest voltage you're going to have in a MacBook, is 59 volts. It's not usually 59 volts, because once you put a load on it, it comes down, and then when you adjust the backlight down a little bit, it comes down. It adjusts the backlight by the voltage. I don't think it's pulse width modulated to the backlight itself. It's actually voltage to the LEDs in the screen is what brings the screen brightness down. So then we're looking over here on the display connector. Here is that output. I'm going to bring it up on the microscope too, so you can see physically what this looks like. What we're looking at here. Get the microscope in focus and switch over to that. So what we're looking at here, this is exactly what we're looking at in that schematic. So backlight voltage is this giant pin here. And then right next to it, you have this tiny little separation of plastic. And you have a data line. So backlight voltage, and then data line, data line. So let's take a look at that on the schematic. You have backlight voltage, data line, right here. So that little piece of plastic, it's not a big gap like it shows here, where this has small gaps and this has big gaps. The layout of the connector is actually the same. So you have 59 volts, possibly. It could be up to 59 volts, with this tiny little gap between two data lines. Now these data lines on this board and any of the larger boards that have a dedicated GPU, they go to a mux. They go to a muxing circuit. So if we follow it here, you're going to see it go up to this chip right here. So now when you get liquid on this connector, that being so close together, it doesn't even have to be that close together even, but there's no ground in between it. We take a look at this connector here. Look at all the extra grounds you have here. You have a group of three. why can't they spare something here and move these two, move this over here? They got into a manufacturing. I don't think that they would think this was an issue. Some engineer didn't think it was going to be an issue because the connector is rated that it's not going to, on normal operating circumstances, nothing's going to go wrong with this. There's enough spacing to hold 59 volts here and not mess with this at all. But still, you have to plan for contingencies. I know consumer electronics don't like to do that. I come from an area of military and automotive. Military and automotive plan for contingencies in everything that they design. They build in redundancies and they build in protections and everything. This would never fly, well, in the old automotive world. I'm sure Tesla does some stuff like this. I wouldn't be surprised if that big screen that they have on there has stuff like this, but you don't do stuff like this in military equipment. You would never ever see this. This is absolutely insane. One of these ground pins would be up here first. These two would be down here where you have extra space for some ground before any high voltages, because this is a data line. But this one is not that bad because this goes to a mux. Now let me open up another schematic here. So when liquid gets on this, it sends the 59 volts down the data line, kills the mux. We open up a 1706 and look at the same thing. It's pretty much the same screen layout, same connector. There's some extra things here. I didn't realize that. LCD interrupt request low. So there's no 3. There's 3 here, but there is some extra. So you got a group of 3 here, so you can move some stuff around and get ground clearance on this. Same thing. LCD backlight out, and your display data lines. So if we click on this here, though, this doesn't go to a mux. This goes to the CPU. Straight to the CPU. Both of them. So if you get liquid on this connector, on the smaller, this is the 13-inch 1706, I believe it's the same for the new 13-inch, goes right to the CPU, and 59 volts or 50 volts will go straight to your CPU, killing this data line. It doesn't kill the CPU. CPU still works. It kills this data line to the CPU. So you will never have internal graphics ever again. You can get external graphics because that still comes out of something else going to the Thunderbolt, but you will never get this graphics back ever again because the CPU is dead in that area. Something interesting that I just found. We never talked about this before. We have talked about this issue before. We even did a collaboration with Dave Jones from EEV blog. He did a video on this too. He thought it was absolutely insane from an engineer's standpoint that they would not put a ground pin between this. Maybe Lewis will link that video, the collaboration video, when he does an edit on this. But we go to the 1708. This is something that I found interesting. So I'm thinking an engineer got fired for this. We go to the 1708, and we have the same exact layout. Same exact thing. LCD backlight and your 2 data lines. But we follow these data lines on the 1708, and lo and behold, look at this. Look at this. An isolation capacitor. An isolation capacitor. Can anybody tell me what a capacitor does? Capacitor has a couple different functions in a computer. It could be used to store energy and release it at a later time. That's on buck regulators for smoothing out the spiky voltages that a buck regulator does, so it stores a little bit of the energy and lets it out when the voltage sags. Or it could be used to filter. It could send a capacitor. A capacitor straight through like this does not allow voltage to go through it. It does not allow current through the capacitor. Only when it charges does it allow anything through. So we can use that to our advantage. This is now isolated from that connector. If that connector gets 50 volts, this capacitor will stop that 50 volts and will not pass it to the CPU. But any fluctuations in voltage, as voltage goes up and down like a data signal does, the data signal will go straight through this capacitor. Every time there's a transition from up to down, that small transition goes through, so data in binary bits will talk to the CPU through the capacitor. But if you get 50 volts on the capacitor is just going to stop it. It's not going to allow it. It's like a bouncer at a club. It will not allow that 50 volts to kill the CPU. I found that very interesting that I saw that on the 1708. The problem with the 1708 though is that we have over here, you have some unfiltered lines. This one right here goes right to the CPU, and this is right next to PP bus. So this is PPVN SOSW backlight. So this is PP bus, and this area gets liquid damaged a lot. This whole bottom area always takes liquid damage in a 1708, and it always puts PP bus to the CPU on these data lines, all 4 of these. And this actually kills the CPU. It'll be brain dead if you have liquid damage. If you have enough liquid damage in here, it kills your CPU on the 1708. So that's another thing that, you know, they did have. This is capacitor filtering, but the problem is that the end point of the data line is right next to a high voltage source. It's not 59 volts, it's 12 volts, but 12 volts is still enough through water to kill the CPU. So if 12 volts is enough through water to kill the CPU, imagine what 59 volts is. But 1708's covered. 1708 will work. So now let's go back to what we're working on today. So that was the 1708 and 1706. They came out, what, in 2016? Was that it? Or 2016, 2017, something like that is when they came out. So here it is in 2019, now with this board, still the same issue. You have the backlight output, the data line goes to the mux, kills the mux. But this is different. What we have here is something a little bit different. So I thought this was interesting. So if you look at the connector, there's nothing wrong with this connector. There's no burns, there's no liquid damage or anything like that in this connector. Most of the time this does happen on the screen though, on the screen side. So let's look at the screen connector. A lot of times we have to change this connector out and everything. It's kind of a pain in the ass. Dan did one a while ago. So this connector's fine. Nothing wrong with this connector. There's some schmutz around it. Not a problem. No burns. You could actually take a multimeter and test one of these when they're burnt, and the plastic between the pins will turn to carbon and turns into a resistor, and you get the power right through that burnt up carbon. But this is fine. So what the issue is here, we have the same issue. The mux is dead. We have no graphics. But take a look here at what I found. If we look at this connector again, the connector's fine, but look at over here. These 2 test points and this capacitor. Let's go back to the schematic. So we're still up on the mux. Let's go back to the connector. So here's the data line we're talking about. Here is those 2 test points right here. That's both data lines that we're talking about. And here's that precariously placed capacitor that's right next to it. See what that says on it? PP bus HS CPU. So this is PP bus. This is 12.5 volts to 13 volts, depending on what PP bus is running. And a drop of water landed directly between PP bus and these 2 test points. So just the power through a drop of water from 12 volts to this killed the mux. So forget about 59 volts. This is only 12 volts through a drop of water is killing this. So luckily with this machine, it doesn't kill the CPU. It only kills the mux. So now we'll clean up this, change the mux, and everything should be fine with this computer. Hey, Paul Daniels, how's it going? What time is it down under? Is it late for you? Like really late? Somewhere in this in the office here, I've been wanting to put up a couple clocks around the room, like what you do in like news or something like that. I have them at home where I have 5 different clocks and they're all different time zones. I've been wanting to put one up here with Sydney or something like that, just to get an idea of what time you have over there. 3 a.m. Christ. You're up late. That's my bedtime here, 3 a.m. I've been seeing you, Paul Daniels, upgrading the Flex board view. I've been seeing you talk about the data and the pinouts and stuff like that, and you're getting people to do the diode mode readings and all that. That's pretty damn cool. That's going the ways of all the automotive software that I used to use. the automotive software did the same type of stuff where you would get common fixes. It would give you like common fixes to problems and stuff, and then they have the user databases that if the car was somewhere else for service, that you can find out what it was there for service for and stuff. Do I have a magnet here? I have a magnet here. For those of you that are against electric screwdrivers, there you go. I know how to use a regular screwdriver. Just prefer the electric one when you're working on so much stuff per day. And a bunch of $1 IKEA clocks. Dedicate one to Paul Daniels. Don't even put Sydney, put Paul Daniels on it. That would be cool. I don't like the IKEA clocks. I actually spent a lot of money for my clocks because I wanted quartz movements. I wanted them to sweep silently instead of having 5 clocks ticking in my living room. We gotta cut this. Exacto? Yes. Electric everything is the way to go. Screwdriver, car, chair. I don't know if I'm completely sold on electric cars yet. I like them. They have some good features and everything. Tesla's the only one that has a really good range. So that's what they really have going for them. But I don't like them as a car builder. Their cars are put together like crap. Get rid of this. And I don't think our country's ready for everybody to switch over for electric cars. The power system just can't handle it. But I think manufacturing's low enough that's really not going to matter. They can't make that many electric cars, so. I have a new Mux. There's the old Mux. Switch over to Microscope. I won't make you dizzy, I'll move it first. Switch over to Microscope. Turn on the soldering irons, fume extractor. So you have to be careful when you're working on this because it's between the GPU and the CPU. So you want to keep your air pointing in one direction only. You don't want to heat up anything unnecessarily around here. And the stuff that you do want to heat up unnecessarily is stuff that doesn't matter, like this chip, the coil here. They're not gonna care that I'm pointing air towards them. What's this, RAM chips and stuff like that up here, VRAM, they would care a little bit. So point your air that way. Let's get a little bit of flux. If solar keeps getting cheaper, people might be enticed to have a home battery and get fuel from the roof of their house. That's a great idea. That is the ultimate if you have an electric car, is that you charge it from your own solar plant that you have on your roof. But the problem is with that is that most of the time you're driving during the day, so yeah, you need batteries. Yeah, home battery storage is not the best. That's still an area that needs more development. That's going to be the next revolution. When we come out with a new revolutionary battery technology, that's going to be a huge day. Whatever company does that effectively, something that's game-changing. I think this tip is too big. It is a really hard area to heat. There's a lot of heat wicking going on there. some new solder down there, some leaded solder, and I need my fume extractor closer. There we go. Sodium-ion batteries, don't they already have them? It's just that, don't they require high temperatures? Wick, who's got the wick? I found the wick. The wick is empty, you sons of bitches. Somebody was working here and used all the wick on purpose. I found some. Nasty little piece of wick. It's getting nice and flat. Let's clean off the spent flux. Notice how my flux did not run away anywhere. There's no flux underneath other chips. There's no flux anywhere else. This will be a constant argument between everybody that works here, how much flux to use. Oh, sodium ion as opposed to regular sodium. It's the regular sodium that needs high temperature. Sodium ion's different. I gotta look into that. Okay, the old Mux was an NXP. These new ones are a different brand. I believe they're Texas Instruments, TI. And these, the replacement ones that we get, are now going out of production. So Texas Instruments promises that they are going to have a replacement to this Mux. But I haven't seen anything towards that yet. I don't know if there's new part numbers. We ordered a supply for a while, because this seems to be, it's going to be a problem for a while. So hopefully when Texas Instruments puts this number completely to bed, we have an alternate number that's fully backwards compatible with it. Nope. It's a little high. No. It should go down there. There we go. Dance, little chip, dance. Okay, we'll do some cooling and cleaning with a Q-tip full of alcohol. Okay, so that's that for changing the Mux. Now I'm going to do some cleanup. I'm going to look around a little bit too, because this did have liquid damage, so I'll look over the whole board before I plug it in. A bit dusty in areas, that's fine. Everything else looks fine. So let's clean off the thermal paste. We'll put on some new thermal paste. Towels. First a dry one, then I'll alcohol one. A little bit of alcohol. It's not lint free, so you got to make sure you don't leave any lint behind. If you clean it up good, the lint doesn't want to stay. I'll clean up the heatsink. No lint. Now, is there thermal paste in here? I have not seen a thermal paste over here since Dan used it. Where is it? Here it is. Ooh, this is empty. I don't know if anything's going to come out of this. Oh, spot of dust. Yeah, something came out of that. Not very well mixed. We'll mix it up a little bit. There you go. A little bit more than I wanted just because I had to mix it. Second part came out good. Push down on it. Some firm but gentle pressure and wiggle it around a little bit. Make sure everything gets spread out. I'll put these back. I don't think it really matters that much, but I always take care too. The short ones had blue Loctite and the long ones had red Loctite, so I always put them back where they belong. I don't think there's any way anything could get loose in here anyway, but I always pay attention to every detail I'm looking at. You should just always do that with every job you do. Everything in life, always pay attention to details. Something that's taught heavily in the Marine Corps. Always pay attention to details, because the details will get you. Life or death situations in war or something, it's the details that'll get you. So it's a good habit to keep yourself in. If a job is worth doing, then it's a job worth doing properly. So yeah, I love that. I love that. That's old. That's an old saying. Well before any of our time, probably. Okay, let's plug this in and see if we have Apple logo. Ooh. Ew. Okay, let's get some MacBook cotton candy first. So we take a Q-tip, preferably one that's a little bit frayed at the end, and we're just going to go around in here and just like you were picking up cotton candy from one of those makers, just go around and pick up all the MacBook cotton candy. look at all that yummy MacBook cotton candy. Oh yeah. Before I'm done, I'll take this outside and blow it out and everything, or use the vacuum on it. 'Cause yeah, the fans are all dirty and everything too, so that'll get cleaned. So this machine is an absolute freaking nightmare with all of its connectors and everything you got to pay attention to when you put this in. I don't understand how this is done on the manufacturing level. All of these fucking connectors all get caught underneath the board. How the hell do they put this board in here in the first place? This must all have like little pieces of Captain holding everything back just so that a technician can put this thing together on the assembly line. What a total fucking waste. This has never been like this. This board going into this machine is the fucking worst. Everything you have to pay attention to make sure it's not underneath the board when you finally let it go. And for everybody playing along at home, yes, I am using metal tweezers. Yes, it is disconnected from power. Forgot one. I'm not hooking all of these up either, but I don't want any stray contact laying behind something so it could short it out. Oh, and then you have the fan rubber too, that's permanently attached, but only swings out and springs right back. So that gets in the way too. I don't know how the hell they do this in the factory. This has got to add to manufacturing cost. This is not made for manufacturing. Imagine that, a consumer electronic that's not friendly to manufacture. What the fuck are you thinking? Okay, these metal pieces out of the way, don't want to be touching anything. Yep. So plug that in, we'll plug one charge port in. Charge port's plugged in. Let me turn off that. You don't need to listen to that noise. We definitely don't need that noise. Wow, this one's really loud. Okay, let's see here. No customer identifying information. Let's get the amp meter. Plug in the amp meter. Plug in here. So we have power, 5 volts, 20 volts, 200 milliamps, 160, 800 milliamps, 1.8 amps, so it is turning on. And we have Apple logo with no backlight. So we have display. So we fixed the display issue with the mux. So we have display, but now we have a backlight issue. So let's see if we could see. Let's check. Short on backlight. Nope, no short on backlight. Let's take a look at the backlight driver. Now I gotta take this fucking thing out. Maybe I should do a PRAM reset before I do all that. Let's plug in the keyboard and trackpad so we get keyboard working, and we'll do a PRAM reset before we do the simple stuff first. KISS, keep it simple, stupid. So if the parameters are saying keep the backlight low, we don't want to go chasing after a dead backlight when all it is low. Let's see, I'm also going to plug in a speaker, so maybe I get an audible indication that the PRAM reset went. Because after a PRAM reset, you should get a chime. Unless you're working on one of those machines that doesn't chime anymore. But once you upgrade to Big Sur, it'll chime again. So first things first, I'm going to do a SMC reset, which is Control Option and that shift, hold it for 7 seconds, and then push the power button, and I'll watch the amperage draw. Oh, I didn't plug in the power button. Duh. Okay. Power button in. Ooh, I keep hitting the microphone on the thing. Sorry, headphone users. Okay, SMC reset took, so now Option Command RP, and we'll wait and see if a PRAM reset happens. Sometimes you have to release the keys. Sometimes it's sitting here in limbo until you release the keys. Okay, we have one chime. There, PRAM reset went. So we should just get another chime, and then backlight should be set to full if the backlight's working. And I see the Apple logo with no backlight. So let's check backlight circuit. Everything disconnected. Could be the screen on this too. I believe a 1707 screen works on this. Anybody in chat know? Chris Long, Paul Daniels? I know I have a whole test housing for this machine somewhere, but I'd like just a screen. I think a 1707 works. Has anybody done that? Let's check the fuse. The fuse is good. Yeah, there's no no corrosion at all on backlight. I want to blame the screen. I'm gonna go get a test screen or the test housing. One moment, please. So I have a 16-inch test screen. So now I have it out of the casing. More room. Oh crap! I forgot to test. I thought I put one out here, didn't I? No. Be right back again. Why, hello. Nice to see you all here. Forgot my charge board. Okay. Overhead. This desk is not really deep enough. Okay. Where can I measure backlight? I can measure backlight on the capacitors. Okay. Let's see what we got. Now this is a good backlight crack screen. So if backlight works on the machine, we will get backlight. On voltage. Let's see, let me just go across these. $51 volts. I has 51 volts. I don't have Apple logo, or I do have Apple logo. Screen's so dirty I can't tell. I just don't see anything. Is there a dull glow of backlight? I have 51 volts. I should have backlight. I still have 51 volts. I have the probes on backwards, but I have 51 volts. I guess I should go get a different screen. So their screen gives me image, no backlight. This test screen gives me nada. It's supposed to be a broken LCD panel, but I should get, you know, like the crazy lines in it and stuff. Is backlight not making it through the cable? Is the cable fucked up? Cable looks fine. Is the screen flex gated? Okay, I have backlight voltage, but this test screen seems like it's shot. It's not giving me anything. Let me try another test screen. I shall be back yet again. Hello. Just give you a little bit of empty chair stream. Everybody loves a good empty chair stream now and then. Okay, so now I have a whole test housing. This test housing, unfortunately, is unknown. We don't know if it's good or not. Overhead? Overhead. And you get used to those buttons. So, same thing as the other one. Let's shoehorn this shit in here. Every time I put one of these boards into these machines, through my head is just going, I hate you, I hate you, I hate you, I hate you, Apple, I hate you, 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 Apple, I hate you, I hate you, I hate you, I hate you. Why, Apple? Why? Doubly why? Mega why? 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 Why would you do this? Why? 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 And then most of the time I forget one of these. Oh my god. And then it's just screamed obscenities inside my head. And that's not fitting because of that. This stupid corner thing. Why? Why? You really have to have that little tiny bit that gets caught on the corner. Seriously? Why? Okay. Power, screen, that's it. Let's see what we got on this. So this is an unknown entity. We have no idea if everything's working in this or not. if anything's working in this or not. And that's not good. This charge port is bad. So I will use my charge port. And plug. And we got 20 volts, 50 milliamps, 200 milliamps, 300 milliamps, 200 milliamps, 800 milliamps, 1.6 amps. And what do I got? Anything? Anything? Oh, Backlight Apple logo, look at that. So, we have another bad screen. I don't have very good luck with any of this stuff, do I? So, another one with a bad screen. Screens are dropping like flies. That's why they're so expensive. We have a hard time getting screens, and people really don't like the price that we can give for screens because screens are not easy to come by for these new machines. We're going to have to start fixing screens at component level. Yeah. So, hope you found that fun to go through. So I found it very interesting. For anybody that just came in, rewind to the beginning and take a look at the explanation when we're all done. I found it very interesting that I found out that the 1708 is actually protected on those data lines. The data does go through a capacitor, a filtering capacitor, a protection capacitor, isolation capacitor is what the actual term. So I don't know why they didn't do it on everything else. Everything else needs in the same spot too. That was placed in the perfect spot, right up against. You can't see it if the heatsink's on. It's so close to the CPU that it's underneath the heatsink. I don't have any of these boards without a heatsink on it. But yeah, there's isolation capacitors right here, as close as they can possibly be, exactly where they should be, to protect from any event like this. And the data has to go through a isolation capacitor before it gets to the CPU. But can't do anything about it, just gotta react to it. They haven't changed this screen setup, screen design, anything yet. So all the new ones, same thing. I did learn Morse code. I was a communications radio repair in the Marine Corps. I forgot it all. I can't make heads or tails of it anymore. That's right out of my head. So sorry for the not so great end. Yep. Have a good day, guys.